Welcome to qnawire.
In this question, we are to predict which one of the isomers would have the lower enthalpy in the following gas phase isomerization reactions. We'll have to calculate the sum of the bond energy for the reactants, which is going to be equal to the sum of bonds broken, the sum of the bond energy for the product, and we only have one reactant and one product, which is equal to sum of bonds formed. And then our delta H would be the sum of the bond energy for the reactant minus the sum of the bond energy for the product. So for A, our isomerization is from ethanol to dimethyl ether. The reactant is ethanol, so sum of the bond energy for ethanol, our reactant, is we're going to break a CC bond. We're going to break a CO bond. And we're going to break an OH bond. And this would give me double check here. Sorry, CO would be, this would be 358. Breaking a CO bond. This is 358 kilojoules. And this would be 1,169 kilojoules per mole. And for the product, the sum of the bond energy for dimethyl ether, we're going to form a CH bond. We're going to form a CO bond. We're going to form two CO bonds, which are 358 and 358. And let's add this together. And this will give me 1,129 kilojoules per mole. And now let's calculate our delta H, which would be 1169 kilojoules per mole. Subtract 1129 kilojoules per mole. And we will get 40 kilojoules per mole, which signifies that this is endothermic and the reactants would have lower enthalpy, so the isomer with lower enthalpy is the reactant, or ethanol. Part B. Our gas phase isomerization for part B is ethylene oxide to acetaldehyde. The sum of the bond energy for ethylene oxide and for B, we're going to break two CO bonds, and they are at 358 kilojoules per mole each. And this would give me 716 kilojoules per mole. And we're going to form, this is acetaldehyde. we're going to form a CO double bond, which is 799 kilojoules per mole. And in this example here, we have delta H, which is 716 minus 799. And we get minus 83 kilojoules per mole, which signifies that it's exothermic, and the products would have a lower enthalpy. So the isomer with the lower enthalpy is the acetaldehyde. For C, our gas phase isomerization is cyclopentane to pentadiene. So the bonds broken for cyclopentane. We're going to break two C-C bonds, which are 348 kilojoules per mole each. And this will give me 696. And we're going to form, this is pentadiene. We're going to form one carbon-carbon double bond, which is 614 kilojoules per mole. Therefore, our delta H here will be 696 kilojoules per mole minus 614 kilojoules per mole. And this will give me 82 kilojoules per mole, positive value, endothermic. So the isomer with lower enthalpy is the cyclopentane. And lastly, for D, we have our gas phase isomerization with methyl isocyanide and acetonitrile. So the sum of the bond energy for methyl isocyanide, we are going to break up a CN bond, which has a enthalpy of 293 kilojoules per mole, and we're going to form acetonitrile. We're going to form a C-C bond, which is 348 kilojoules per mole, and the delta H here will be 293 minus 348, and this will give me an enthalpy negative 55 kilojoules per mole, exothermic. Therefore, the products have lower enthalpy, so the isomer with lower enthalpy is the acetonitrile.